Hey, what's up guys? Today we're going to go over the parietal cell and how it synthesizes and secretes hydrochloric acid into the stomach lumen. So first let's orient ourselves. On the left here you'll see our blood supply. In the middle you'll see our parietal cell, and on the right you'll see the stomach lumen. So first thing first, let's get the building blocks we need to secrete hydrochloric acid. We're going to uptake CO2 from the venous blood, which will just diffuse into the parietal cell. In a reaction you may have seen before, this CO2 is going to react with water, forming carbonic acid. This is catalyzed by the enzyme carbonic anhydrase. Then our carbonic acid is going to dissociate into a proton and a bicarbonate. So now let's deal with how we get rid of bicarbonate. On the basolateral side of the parietal cell, there's an antiporter which will exchange one bicarbonate for one chloride. The result is that we will get bicarbonate into our blood supply and then it will flow away from the stomach. You may have seen this referred to as the alkaline tide, which refers to the phenomenon in which the venous drainage of the stomach will be basic after a meal due to this higher concentration of bicarbonate. Now we've gotten chloride into the cell, let's get it into the lumen. On the apical side of the parietal cell, chloride will just diffuse through a channel into the stomach lumen in what is referred to as facilitated diffusion. So now let's get rid of our proton. On the apical side of the parietal cell, the H+ is going to leave via a hydrogen potassium antiporter, which is an ATPase. So it's going to use the energy of hydrolyzing ATP to pump a proton out and a potassium back into the cell. It needs energy because the potassium is moving uphill against its concentration gradient here. So how do we sustain this? Because extracellular potassium levels are usually quite low. So our parietal cell also has a K+ leakage channel, which will allow potassium to leak out of the cell and into the stomach lumen, providing an ample source for this hydrogen potassium antiporter. This is going to create this loop where potassium leaks out of the cell and is pumped right back in through this hydrogen antiporter ATPase. Also of note, the negative chloride leaking out into the stomach lumen is going to further increase the electrochemical driving force on the potassium ion and increase potassium leakage, allowing us to pump more protons into the stomach lumen. Thanks to our ATPase and leakage channels, we now have hydrochloric acid in the stomach lumen to help degrade all of our delicious food. As we know, the stomach needs this acidic environment to help degrade our food, as well as activate enzymes such as pepsin that also get released in the stomach. Now that you know how the stomach synthesizes hydrochloric acid, you should look into how it's regulated, and I'll link a video in the description down below. Thanks for watching, and I hope you found that helpful.